pH scale is a measurement of the concentration of hydrogen ions dissolved in aqueous solution. So if the pH is 1, it corresponds to a hydrogen ion concentration of 0.1 moles per decimeter cubed. Similarly, if it's 7, the H plus concentration is 1 times 10 to the minus 7 moles per decimeter cubed. What the scale does is it compresses a very wide range of hydrogen ion concentrations into convenient numbers over a much narrower range. So for example, if you go from pH 7 to pH 1, you are increasing the concentration of H plus ions a millionfold. And similarly, if you go from pH 14 to pH 7, you're increasing the H plus concentration 10 millionfold. Whereas the numbers are changing, they're all in the same order of magnitude, so much more convenient. Now you can see that there's a relationship between the power to which 10 is raised, here it's minus 7, and the pH. Here it's minus 14, and the pH is 14. And of course another way of writing 0.1 would be 1 times 10 to the minus 1, and again that is the pH with the sign changed. It's worth just looking at the origins of the pH. It means minus the logarithm to the base 10 of the hydrogen ion concentration. So let's just look at what we mean by a log to the base 10. The log to the base 10 of 100, for example, is 2. What that means is that 2 is the power to which the base must be raised to give the number whose log we're looking for. So I can write here, the base is 10, if I raise that to the power 2, it gives me 100. Okay, so the log to the base 10 of 100 is 2. Now the pH is simply the minus the log to the base 10 of the hydrogen ion concentration. So if I write that down, pH is the minus of the log to the base 10 of the hydrogen ion concentration. So if, for example, we have hydrogen ion concentration of 0.1 moles per decimeter cubed, pH equals minus the log to the base 10 of 0.1. So the logarithm of 0.1, it's the power to which 10 must be raised to equal 0.1. So it's going to be 10 to the minus 1. So you can just do that on your calculator. Just do log of 0.1 and you get minus 1. So log to the base 10 of 0.1 equals minus 1. If you then change the sign, so you could times it by minus 1 if you like, then you get 1. So the pH of a solution whose hydrogen ion concentration is 0.1 moles per decimeter cubed is 1. Now, at A-level chemistry, you will only ever deal with logarithms to the base 10, so we don't normally write the base. So I'll just write it like that. I'll give you another example. Let's just say, what is the pH of solution if the hydrogen ion concentration is, say, 0.2? So if H plus equals 0.2 moles dm to the minus 3. So the first thing we do is we take the logarithm of 0.2. So log 0.2, and on the calculator, log of 0.2 equals, it's minus 0.69, but I'll put minus 0.7, and then you reverse the sign. So you pH equals 0.7. So again, you can imagine you're multiplying by -1 to change the sign. And it's possible to go the other way, the other direction. So let's just say if the pH is 5, pH equals 5, what is the hydrogen ion concentration? H plus equals 10 to the minus 5. So you change the sign and then use that as the power to 10. Now that's an obvious one. Let's look at another one. Let's say the pH equals 6.8. So you would do 10 to the minus 6.8. And on your calculator you have, mine has a special key. It's got a 10 with a little box there. So I just press that key, so 10 with a little box, and in there I put minus 6.8. Okay, and which is this one, and then I press equals, and I get 1.58. I'll just call that 1.6. 1.6 times 10 to the minus 7. So that would be the hydrogen ion concentration. So we can always check this. It's always a good idea if you're not sure of your answers to work backwards again. So the log of 1.6 times 10 to the minus 7. So I just go log 1.6 10 to the minus 7, and I get minus 6.79. I put minus 6.8, and so the pH would be that with the sign changed, so it would be 6.8. Okay. I can summarise this for you. Imagine you have the H plus concentration here, and you have the pH down here. If you want to go from a hydrogen ion concentration to a pH, you take the log. That's the first thing that you do. And then you reverse the sign. Reverse the sign. And similarly, if you have a pH and you want to work out the hydrogen ion concentration that corresponds to, you just do power of 10 to the minus pH.